Today we will talking about linear differential equations with constant coefficients. Okay, so what is the meaning of linear? So linear means a differential equation of degree 1. Okay, a differential equation of degree 1. And you know order. Order means let y is equal to function of x, means y is dependent variable and x is independent variable. So derivative of y with respect to x. So how many times maximum differentiation of y with respect to x is called order, and degree of maximum order of differential equation is called degree. So a differential equation of degree 1 is called linear. Okay, so in this chapter we will study degree 1 differential equation and coefficients are constant. So a differential equation of the form dny upon dxn plus a1 dn minus 1y upon dxn minus 1 plus a2 dn minus 2y upon dxn minus 2 plus up to so on a and y is equal to qx, where q is a function of x. Okay, here a1, a2 up to an are constants. Okay, so here it is clear that coefficient of dny upon dxn is 1 always. So for these differential equations we will solve very easily. So there are two cases. First case is when right hand side means qx is equal to 0, and second case is qx not equal to 0. Okay, so first we will study when qx is equal to 0. So in this case, when qx is equal to 0, so first we calculate auxiliary equation. Also you remember d over dx equal to capital D, means this notation capital D is nothing but d over dx. So this can also be written as capital dn upon dxn. Okay, so in this chapter we will use capital D also. So now suppose if this is a very simple differential equation of order 2, d2y upon dx2 plus 5 dy by dx plus 6y is equal to 0. So here order of this differential equation is 2, okay, and degree is 1. So this is linear, and here 5, 6 are coefficients which are constant. Okay, so we shall solve these type of differential equations. Okay, so first I want to explain about auxiliary equation, means what is auxiliary equation of any differential equation. Okay, so suppose this is a linear differential equation with constant coefficients of order 2. Okay, so I am going to explain by taking a very simple example. So this is a linear differential equation with constant coefficients of order 2. Okay, so let us suppose solution of this differential equation is y is equal to e to the power mx. Okay, so here if we calculate dy by dx, so this is equal to m e to the power mx, d2y upon dx2 is equal to m square e to the power mx. Okay, so since this is y is equal to e to the power mx is solution of this equation, so by putting value of y dy by dx d2y upon dx2, so we get m square e to the power mx plus 5m e to the power mx plus 6 e to the power mx equal to 0. So first we take common, means e mx m square plus 5m plus 6 equal to 0. So here e to the power mx does not equal to 0. So m square plus 5m plus 6 equal to 0. Okay. So first you see this is a linear differential equation of order 2. So first we calculate auxiliary equation of this differential equation. Okay, so what is auxiliary equation? So here you see m square plus 5m plus 6 is equal to 0. So this is very easy. It means you put y is equal to 1. Y is equal to 1. dy by dx is equal to m. Okay, d2y by dx2 is equal to m square. So we get this equation. So this is called auxiliary equation, and in short form we write here AE. So AE is m square plus 5m plus 6 is equal to 0. So this is very easy. This is a simple equation in m. Means we have studied algebraic equation. Means this is second degree equation in m. So we calculate value of m. Okay, suppose m is equal to, this is 3m plus 2m. So m is equal to minus 2 and minus 3. So there are two solutions. Y is equal to e to the power minus 2x and y is equal to e to the power minus 3x. So both are solution of this equation. So these are satisfied. So how we will write? So solution is y is equal to c1 e to the power minus 2x plus c2 e to the power minus 3x. Okay, here where c1 and c2 are constants. How many constants? Two constants. Two constants explain that our differential equation have order 2. Okay, these constants shows that our differential equation of order 2. So this is a simple case. Okay, so I want to generalize this thing. Means if given differential equation of order n, means a differential equation of order n, so first coefficient of d and y upon dxn is 1, means this is 1 always, plus a1 dny upon dxn minus, here minus 1, plus a2 dn minus 2y upon dxn minus 2 plus any is equal to 0. Okay, so first I want to explain when q is equal to 0 means a linear differential equation of order n, okay, with constant coefficient. So first you see this is equal to 1 and q is equal to 0. So this is called linear differential equation with constant coefficients of order n. So any differential equation, if you want to solve, so first you calculate auxiliary equation. This is auxiliary equation. Okay, so this is auxiliary equation in terms of m. So this is f of m equal to 0. Okay, if suppose this is order 2, so this is in terms of m square. If order is 3, so maximum of degree of m is 3. So this depend on order. Okay, so maximum order is 4 in whole differential equation in your syllabus like BSc second year class, or more than maximum 4 degree. Okay, so you will study maximum 4 degree equation, means f of m equal to 0 means degree of m is 4. So we can solve simple equation and we get value of m is 4, m1, m2, m3, m4. Okay, So this is auxiliary equation. So our aim is to calculate value of m. Okay, so now the differential equation depend on value of m, means we solve like we have explained for second degree. So first you see this is differential equation, so we calculate auxiliary equation. What is auxiliary equation? M square plus 5m plus equal to 0, and then calculate value of m. So this is a solution. So in general case, if order is m, so we get a equation of m degree in m degree. Okay, means here if order is n. Now I want to explain solution for roots of auxiliary equations. Okay, so first is when all roots are distinct, means if roots are m1, m2, m3. Okay, then in this case our solution is y equal to c1 e to the power m1x plus c2 e to the power m2x plus c3 e to the power m3x plus up to so on. Okay, now case second, when two roots are equal, when two roots are equal means m1 is equal to m2 and remaining roots are different. So in this case solution is y is equal to c1 plus c2x e to the power m1x plus c3 e to the power m3x. Similarly, case third, when three roots are equal, in this case solution is y is equal to c1 plus c2x plus c3x square e to the power m1x plus for different root. Okay, now case 4 is when roots are imaginary. It means if roots are, suppose m equal to alpha plus minus I beta. So in this case we can write in three different ways. Okay, so first is y is equal to e to the power alpha x c1 cos beta x plus c2 sin beta x, or y is equal to c1 e to the power alpha x cos beta x plus c2, or c1 e to the power alpha x sin beta x plus c2, where c1 and c2 are constant of integration. Okay, now also if imaginary roots are equal, means if a given equation of 4 degree, so if m is equal to alpha plus minus I beta and alpha plus minus I beta, in this case complete solution is y is equal to e to the power alpha x c1 plus c2x cos beta x plus c3 plus c4x sin beta x. Okay, now next, when roots are spherical, means in form of surd, so m is equal to alpha plus minus root beta. Okay, so in this case there are three different solutions. First is y is equal to e to the power alpha x c1 cos hyperbolic root beta x plus c2 sin hyperbolic beta x. Similarly, y is equal to c1 e to the power alpha x cos hyperbolic root beta x plus c2, or this can be written y is equal to c1 e to the power alpha x sin hyperbolic root beta x plus c2, where c1 and c2 are constant of integrations. Okay, this is a summary for auxiliary equations. Means if our auxiliary equations have different roots, so this is very useful to solve the solution of differential equations. Okay, so this is very nice summary table for roots of auxiliary equations. Okay, now we will study for different cases. Okay, so first, roots are distinct of auxiliary equation. Okay, so let us suppose this is a differential equation d3y upon dx3 minus 9 d2yy dx2 plus 23 dyy dx minus 15y equal to 0. So this can also be written dq minus 9d2 plus 23d plus 15y equal to 0. Okay, so first we calculate auxiliary equation. So what is auxiliary equation? We put in place of d is 1 m. In place of d is equal to m. So m cube minus 9m square plus 23m minus 15 equal to 0. Okay, then we calculate value of m. Here this equation is of degree 3 in m, so we get value of m is m1, m2, m3, means 3 values of m. So this is very easy to calculate. Here 23 plus 1 24, 15 plus 9 24. So first you apply by inspection method. Okay, here m is equal to 1 is a root, so you put m is equal to 1 and divide, so we get second degree equation, which is very easy to solve. Okay, so I am going to put direct value of this equation, means m is equal to 1, 3 and 5. Okay, how you solve? So m is equal to 1 is a root, so first you divide m minus 1, so you get second degree equation, and second degree equation is very simple. So here m1 is equal to 1, m2 is equal to 3, m3 is equal to 5. So as we explain, the summary of auxiliary equations means all three roots are distinct, so you put in this solution y is equal to c1 e to the power m1x plus c2 e to the power m2x plus c3 e to the power m3x. Okay, therefore solution is y is equal to c1 e to the power x plus c2 e to the power 3x plus c3 e to the power 5x. Okay, this is the solution. Second, auxiliary equation having equal roots. So suppose this is a differential equation. Okay, so first we will write auxiliary equation. So here auxiliary equation is m square plus 2m plus 1 equal to 0. Okay, so this is very easy to solve. M plus 1 whole square means m is equal to minus 1 minus 1. So two roots are equal. So when two roots are equal, then you will use m1 is equal to m2 equal, so c1 plus c2x e to the power m1x, and for different root. Okay, so here solution is y is equal to c1 plus c2x e to the power minus x. Okay, and similarly, if any equation of order 3, okay, so let us suppose R4. So second differential equation is, suppose d4 minus d cube minus 9d square minus 11d minus 4 y is equal to 0. Suppose this is a differential equation of 4 order. Okay, d4, d capital D is nothing but d over dx. Okay, so if you have a differential equation of order 4 with constant coefficients, okay, d4 minus d cube minus 9d square minus 11d minus 4. Okay, so first you calculate auxiliary equation. So this is auxiliary equation, m4 minus m cube minus 9m square minus 11m minus 4 equal to 0. So how you will solve? So first you see by inspection method. This is constant 4. So how many divisor are 4? So you put 1, 2 and 4. So plus minus 1, plus minus 2, plus minus 4. This is inspection method. First you put 1 and see are this equation satisfied or not. So here if you put m is equal to 1, so this is 1 minus 20, 21, this is not satisfying. Okay, minus 1 will also not satisfy. So you put 2. Okay, you put 2. So here after 1 you put minus 1. Okay, so if you put minus 1, so here this is plus, this is plus. So and this is minus 9, minus 4, minus 13, and in plus 1, 9, 10, and this is 13. So minus 13 plus 13, 0. It means m is equal to minus 1 is a root. Okay, so first you divide m is equal to minus 1. So you get third degree, and same by inspection method you can solve. Okay, so here this is very easy to solve. M is equal to minus 1, minus 1, minus 1. Okay, and since this is 4 degree, so m is equal to 4, another value you can calculate very easily. Okay, so there are 3 roots are equal. So what is solution? Solution is y is equal to c1 plus c2x plus c3x square e to the power minus x plus c4 e to the power 4x. So our aim is to focus how you will write solution. Okay, because this is a simplest method, simple equation. Okay, this is 4 degree equation in m, so you can solve very easily. Okay, by inspection method, and then this is degree of 3, so you can solve very easily. So this is the solution. This is the second case, means when auxiliary equations having equal roots. So how you will write the equation, solution of the equation. Okay, now next, auxiliary equation having imaginary roots. Okay, means roots of the form m is equal to alpha plus minus I beta. So let us suppose this is a differential equation. Okay, so first you write d2 plus 2d plus 5y equal to 0. So this is a differential equation, linear differential equation of second order with constant coefficients. Okay, so now what is auxiliary equation? So m square plus 2m plus 5 equal to 0. So here we will solve m is equal to minus b plus minus b square minus 4ac upon 2a. Okay, so value of auxiliary equation m is minus 1 plus minus 16, so 4I upon 2, here 2. So this is minus 1 plus minus 2I. Okay, so here the root of this equation alpha plus minus I beta. So as we have explained before, if roots are imaginary, so alpha plus minus I beta. So you can write, there are 3 forms. You can write any one. Okay, so either you will write this thing or this or this. So this is the solution. Means solution is y is equal to c1 e to the power alpha x, alpha is nothing but minus 1 plus, sorry, c1 e to the power alpha x cos beta x plus c2. Okay, so you can write either this or e to the power alpha x c1 cos beta x plus c2 sin beta x. Okay, or c1 e to the power alpha x sin beta x plus c2, as you want. Okay, all the solution are correct. Now we will explain about particular integral. Okay, so what is particular integral? So as you know, we have discussed before the linear differential equations with constant coefficients. Okay, it means a differential equation of this form. So we have already solved by taking q is equal to 0, means k is first. Now we will solve for q is not equal to 0. Okay, so in this case we will divide in two parts of given equation. First, we will solve by putting right hand side 0, means q is equal to 0, and solved by previous questions. And for q we will calculate particular integral. Okay, and then solution will be complementary function plus particular integral. Okay, so y is equal to cf complementary function plus particular integral. It means when equation of the form f of dy is equal to q. So first we put f of dy is equal to 0 and we will solve as previous questions. So that solution in present case called complementary function. Okay, so for this we will get cf, and for right hand side q we will calculate particular integral for q. Okay, so how we calculate? So let us suppose f dy is equal to q. So particular integral is equal to q upon f of d. Okay, and then solution is y is equal to cf plus pi. Okay, so now I want to explain pi. Means if this q is of the form linear. Okay, so particular integral means y is equal to q upon d minus alpha. So how we calculate this type? So first we multiply d minus alpha. So d minus alpha y is equal to q. As you know, capital D is nothing but d over dx. Okay, so this is very easy. dy minus alpha y is equal to q. Also, you know q is function of x. Okay, so this is dy by dx minus alpha y is equal to q. So this is a linear differential equation. Linear in y. So integrating factor is e to the power p dx. So minus alpha dx. It means minus alpha x. And what is solution? So solution is q integrating factor minus alpha x equal to sine of integral. Solution is y into e to the power minus alpha x is equal to sine of integral q integrating factor dx plus some constant c. So y is equal to e to the power alpha x integral q e to the power minus alpha x dx plus c. So in the case of particular integral, we put here c is equal to 0. Okay, so therefore in this case by putting c is equal to 0, so y is equal to e to the power alpha x q e minus alpha x dx by putting c equal to 0. Now particular integral, what is y? So y is q upon d minus alpha. So you remember this should be e to the power of alpha x q e to the power minus alpha x dx. So this is important for any question. This is very important. Okay, so q upon d minus alpha x, alpha is equal to e to the power alpha x q e to the power minus alpha x dx. So this is the formula for particular integral. Okay, now an example means equation d2y upon dx2 minus y is equal to 2 plus 5 to 5x. It means here right hand side q is not equal to 0. So how we'll solve? Okay, so first we calculate auxiliary equation. So by putting right hand side is equal to 0, so this is m square minus 1 is equal to 0. So this is as previous we have calculated differential equations of second order by putting k is equal to 0, this q is equal to 0. Okay, so now I am going to explain for q is not equal to 0. Okay, so suppose this is a differential equation. Here q is not equal to 0. So how we will solve? So first we will put q is equal to 0 and calculate auxiliary equation. So as we have solved previously, means equations of the form when this thing equal to 0. So first we calculate a m square minus 1 is equal to 0. So here m square is equal to 1. Value of m is equal to 1 and minus 1. So here we first calculate complementary function. Okay, complementary function is, since value of m are distinct, so c1 e to the power x plus c2 e to the power minus x. As we know, m1 and m2 are different, so c1 e to the power m1x plus c2 e to the power m2x. Okay, now we will solve particular integral. Okay, so now particular integral. So what is q? Q upon fd. Q upon fd. Okay, what is fd? So d2 minus 1. You can write also this equation d2 minus 1 y is equal to 5 plus 2x. So this is fd. Okay, so here q is 5 plus 2x upon fd is nothing but d square minus 1. Okay, so here since f of d is equal to d square minus 1, only we take d, this function of d. Okay, so now we have the formula q upon d minus alpha, means in linear, in terms of d linear. So first we factorize this function fd, so 5 plus 2x upon d minus 1 d plus 1. Okay, and then we will solve by partial fraction, so 1 upon d minus 1 and d plus 1. Okay, this thing, this. And how we calculate? So by partial fraction. So here d minus 1 means d is equal to 1, so 1 plus 1 2. So here 1 by 2. D plus 1 is equal to 0, d is equal to minus 1, so here minus 1, so minus 2. Okay, this is. So this is very easy. 1 upon 2 is common. So 1 upon d minus 1, 5 plus 2x and 1 upon d plus 1, 5 plus 2x. But here minus, so here this is minus. Okay, now we will use the formula. What is the formula? Q upon d minus alpha is equal to e to the power alpha x q e to the power minus alpha x dx. So in first term here alpha is 1, so this is equal to 1 by 2 e to the power alpha x, means e to the power x, sign of integral e to the power minus alpha x, so minus x, and here 5 plus 2x dx. Okay, and similarly minus, here alpha is minus 1, so e to the power minus x, sign of integral e to the power plus x, 5 plus 2x dx. Okay, so this is very easy to calculate. Okay, now we will solve further. Means this is simple integration. So by using the formula integral by part. So here e to the power x, this is, you can write 5 e to the power minus x dx, 5 e to the power minus x dx plus, this is 2 integral x e to the power minus x dx. Okay, so this is first term, and similarly minus e to the power minus x, this is second term, so 5 e to the power x dx, this is common, and similarly minus 2 integral x e to the power minus x dx. Okay, this thing. So this is very easy to solve. 1 by 2, here e to the power x, 5, integral of this thing is minus 5 for minus x plus 2 by integral by parts. Okay, so first function as it is, integral of minus x minus differential of first one, integral of second minus 6 for minus x, so minus minus plus, but again minus x, this thing. Okay, and similarly minus e to the power minus x, this is this thing, 5, this is e to the power x, very easy. Okay, now minus 2. Okay, x integral by part, first function and second function, so first function x as it is minus this thing minus sign of integral, differential of first one e to the power minus x, so minus e to the power minus x, so here plus, but again e to the power minus x. Okay, so this thing, this is, so this is very easy to calculate. You, this is simple calculation. So if you solve, though, you get 1 by 2. So now this is an example. 4 d2y upon dx2 plus 4 dy by dx minus 3y is equal to e to the power 2x. Here right hand side means q is not equal to 0. So first we calculate auxiliary equation. So what is auxiliary equation? So 4m square plus 4m minus 3 equal to 0. Okay, so this is very easy to factorize. 2m minus 1 and 2m plus 3, okay, equal to 0. So here m is equal to minus 3 by 2 and 1 by 2. Okay, so here roots are distinct, so CF is C1 e to the power minus 3 by 2x plus C2 e to the power 1 by 2x, because we know when roots are distinct, C1 e to the power m1x plus C2 e to the power m2x. Okay, now particular integral. What is particular integral? So right hand side means q e to the power 2x upon fd. So what is fd? So you can write also 4d2 plus 4d minus 3y equal to e to the power 2x. So this is fd. Okay, so this is equal to e to the power 2x upon, what is fd? So 4d square plus 4d minus 3. So as we know, we have explained for particular integral, if q is equal to e to the power ax. Okay, so we will use the formula when q is equal to e to the power ax. So e to the power ax upon fd is equal to e to the power ax upon fa, provided fa not equal to 0. So first you see what is a. So a is 2. Since 2 is not a root of this equation, in auxiliary equation 2 is not a root of this auxiliary equation, therefore this formula can be used. Okay, so here e to the power 2x upon, in place of d we will put 2, so 4 2 square plus 4 2 minus 3. So this is e to the power 2x upon 4 16 plus 8 minus 3 is equal to e to the power 2x upon 21. Okay, so what is solution? So solution is y is equal to cf plus pi. So what is cf? So c1 e to the power minus 3 by 2x plus c2 e to the power half x plus e to the power 2x upon 21. Okay, so you can solve by this formula. So in right hand side, if you have e to the power ax upon fd when fa is equal to 0, so you put multiplying numerator x and differentiating 1 times fd and then putting xd is equal to a. So if again f is equal to 0, so again you differentiate denominator with respect to d and multiplying x square in numerator and then put d equal to a. So in general, when this type e to the power ax upon d minus alpha to the power n fd, so this is the formula when phi f is equal to 0. So here in this case x to the power n upon factorial n e to the power ax upon fa. Okay, now when right hand side is sine ax, means sine ax upon fd square, so you put d square is equal to minus a square. Okay, similarly when cos ax upon fd square, so you put d square is equal to minus a square. Okay, but when d square plus a square, means when fa square is equal to 0, if this case failed. Okay, so here cos ax upon d square plus a square is equal to x upon 2a sin ax, and sin x upon d square plus a square is equal to minus x upon 2a cos ax. Okay, if right hand side q is only function of x, means x square x cube, in this case we will remember this formula. So for q is equal to only x square x cube, we will explain some examples. So first you remember this binomial theorem. Okay, 1 plus d to the power minus 1 is equal to this thing, 1 minus d to the power minus 1 is equal to this thing, and this. Okay, so this is very important table for calculation of particular integral. Okay, so you remember it. More examples. So here equation d2y upon dx2 minus 4y is equal to e to the power x plus sine 2x. Okay, so first you write auxiliary equation. So here auxiliary equation is m square minus 4 equal to 0. So m is equal to 2 and minus 2 because m square is equal to 4. Okay, so roots are distinct. So complementary function is c1 e to the power 2x plus c2 e to the power minus 2x. Okay, now particular integral. So particular integral q have two parts. Okay, q has two parts. So first we calculate e to the power x and then sine 2x, or as you like, you can calculate both. So now particular integral e to the power x upon d2 minus 4 plus sine 2x upon d2 minus 4. This is fd. You can write also d2 minus 4 y is equal to e to the power x plus sine 2x. Okay, so this is fd. So now, as you know, formula of e to the power ax upon fd. What is the formula? So e to the power ax upon fd is equal to e to the power ax upon fa. Means you put in place of d is equal to a, provided fa is not equal to 0. So e to the power ax, what is a? A is 1. So 1 square minus 4 plus sine ax upon d square minus a square. Since if we put here sine ax upon f d square 1 upon minus a square sine ax, okay, but this formula we use when f minus a square is not equal to 0, okay. So here if we put a square is equal to minus d square is equal to minus a square, so sine 2x upon minus 2 square and 4 minus 4, okay. So this is e to the power x upon 1 minus 4, so minus 3, here minus 8 sine 2x upon 8, okay. So this is pi. So solution is y is equal to cf plus pi. So this is answer. Now this is next example. Means here I want to explain when q is x, rx square, rx cube, rxn. In this case, when q is x to the power n, so how we will solve the differential equation, okay. So first you see this is d2 minus 4y equal to x square. So first we calculate auxiliary equation, okay. So m square minus 4 equal to 0 implies m square is equal to 4. So m is equal to plus minus 2, okay. So complementary function is c1 e to the power 2x plus c2 e to the power minus 2x, which is very easy, okay. Now our aim is to calculate particular integral. So here particular integral right hand side q is either x, x square, x cube. So q and x square upon fd, d square minus 4. So in this case our aim is to find the value of this thing in numerator, okay. So here d x square upon, first you take common constants, or here minus 4, so we take common minus 4, so this is 1 minus d square upon 4, okay. So now this is 1 upon minus 4, 1 minus d square upon 4, here minus 1 x square. So first you solve denominator, okay, and our aim is to calculate either 1 minus d, 1 plus d, okay, or 1 minus function of d, and then this will be in numerator, so power minus 1. Now we will use the formula. What is the formula? So here we shall use the formula for 1 minus d to the power minus 1. So which is 1 plus d square plus d cube plus d4 up to number of infinite terms, okay. So here since power of x is 2, so maximum we can differentiate 2 times, okay. So here by using the formula, this equal to minus 1 by 4, 1 plus d square upon 4 plus d4 upon 16 plus up to so on. Since here x square, so only differentiation is possible 2 times, okay. So this can be written as minus 1 by 4, we operate in first term, so x square plus d2 upon 4 x square, means differentiation of x square 2 times. So if we differentiate once, so 2x and then only 2, so 1 by 4 into 2, and remaining term will be 0 because d4 means 4 times differentiation and all the terms are 0, okay. So plus 0, okay. So now this is minus 1 by 4 x square plus 1 by 2. So this is particular integral. So now solution. What is solution? So solution is y is equal to CF plus PI. Okay, so what is CF? C1 e to the power 2x plus C2 e to the power minus 2x but plus pi means minus 1 by 4 x square plus 1 by 2. So this is solution. Okay, some important questions. So very important question. d2y upon dx2 plus 4y is equal to sine square x. Okay, so first we calculate auxiliary equation. Okay, so this equation can also be written as d2 plus 4 y is equal to sine square x. So here auxiliary equation is m square plus 4 equal to 0. So m square is equal to minus 4 implies m is equal to plus minus 2y. Okay, so as you know we have explained when value of m is alpha plus minus I beta, alpha plus minus I beta. So the complementary function is c1 e to the power alpha x cos beta x plus c2. Okay, when value of m is alpha plus minus I beta, then formula of this thing CF is this. Okay, so here alpha is 0, beta is 2. So here CF is C1 e to the power 0x cos 2x plus C2. So 0x is nothing but 1. So CF is C1 cos 2x plus C2. Okay, now particular integral. Particular integral means q. So what is q? Sine square x upon d square plus 4. So now first you think here q is sine square x, but we had the formula for sine ax or cos ax. Okay, so since sine square ax is equal to 1 minus cos 2x upon 2. Okay, so this can be written as 1 minus cos 2x upon 2 and d square plus 4. Okay, so here this equal to 1 by 2 1 upon d square plus 4 minus cos 2x upon d square plus 4. Okay, so since first term is 1, so you know pi of e to the power ax upon fd is equal to e to the power ax upon f of a. Okay, and similarly cos ax upon fd square, so here you put minus but this is 0, so we shall use the formula cos ax upon d square plus a square is equal to x upon 2a sine ax. Okay, so these formula we will use here. So you can write e to the power 0x because e to the power 0 is 1. So here the formula e to the power ax upon fd equal to e to the power x upon fa. So you put in place of d equal to a. So here we put d equal to 0. So this is 1 by 4 minus cos ax upon d square plus a square is equal to x upon 2a sine ax. So here d a is 2. Okay, a is 2. So here x upon 2 into 2 4 sine 2x. Okay, so this is particular integral. Therefore solution is y is equal to cf plus pi. Y is equal to cf plus pi. So you can write y is equal to c1 cos 2x plus c2 plus 1 by 8, you take common 1 by 4, so 1 by 8 1 minus x sine 2x. Okay, so this is the answer. Also if the value of m is alpha plus minus I beta. So we have explained before, you can write in three ways. Okay, means e to the power alpha x c1 cos beta x plus c2 sin beta x, and one is c1 e to the power alpha x cos beta x plus c2. Okay, and other is c1 e to the power alpha x sin beta x plus c2. Okay, so any one you can write here. So this is the solution of this very important question. Now we will explain the method to calculate particular integral when q is equal to x into v, where v is function of x. Okay, so in this case particular integral is equal to q upon fd. Okay, particular integral pi equal to q upon fd means x into v upon fd. So in this case we will write x v upon fd plus dy by dd 1 upon fd into v. It means first we write x and then particular integral of v means v upon fd plus differentiation of 1 upon fd into v. So we will explain by an example. Okay, so let us suppose this is an example. So in right hand side x into function of x. So first we will write d2 minus 2d plus 1 y equal to x sin x. Okay, now this is very easy because left hand side is very easy. We have solved so many equations. So a is m square minus 2m plus 1 is equal to 0, and this is m minus 1 ka whole square of m minus 1 means m is equal to 1 1. So we have, if roots are equal, then c of equal to c1 plus c2x e to the power 1x. It means x. Now particular integral. So q means x sin x upon d minus 1 square. Okay, this is pi. So as we know, what is the formula? Formula is that first we will write x v upon fd. So here equal to x. What is v? So v is sin x. So in this case sin x upon d minus 1 square. So this is first term. Okay, and what is next term? Plus dy by dd 1 upon fd into v. So here plus dy by dd 1 upon d minus 1 square and into sin x. Okay, so as we know, particular integral of sin ax. So since sin ax upon f d square equal to sin ax upon f minus a square. Okay, so here this equal to x sin x upon d square minus 2d plus 1. Okay, here this is 1 upon d minus 1 ka whole square means this is the minus 2 d minus 2 upon d square minus 1. It means d minus 1 ka whole square means d minus 1 square of d minus 1 means d square minus 2d minus 1 square. Okay, into sin x. So here we will use the formula. Here in place of d square is equal to minus a square. A is 1. So this equal to x sin x upon minus 1 minus 2d plus 1. Okay, and similarly minus 2 d minus 1 upon, here also in place of d square minus 1 minus 2d minus, here also plus 1, okay, into sin x. So in first term, here this cancel, x by 2, this is constant, so this is 1 upon d sin x, okay, this thing, and here minus 2d minus 1 upon, here 1 cancel, this is minus 2d square and 4d square, means 4d square into sin x, okay. I think this is clear. So next term is, you know, d means differentiation, okay, like d means differentiation, so 1 upon d means integration, okay. So you know this is notation. So here x by 2 integration of sin x, so minus cos x minus 2d minus 1 upon 4, 1 upon d square means integration 2 times, integration of sin x 2 times, you know, sin x upon d square, okay. So x cos x by 2 minus d minus 1 by 2, 2 and 4 are cancelled. So now sin x upon d square means 1 upon d means integration with respect to x, so d square, 1 upon d square means integration 2 times, so integration of sin x is minus cos x and cos x is sin x, so this is minus sin x, okay. So now this equal to x cos x by 2 minus plus. Now we operate d of sin x means cos x minus 1 into sin x, so sin x by 2, okay. So this is particular integral. So we will write here cos x is common, so we can write x plus 1 by 2 cos x minus sin x by 2. So this is pi. Now solution. The solution is y is equal to cf plus pi, okay. It means y is equal to c1 plus c2x e to the power x plus x plus 1 by 2 cos x minus sin x by 2, okay. So this is the answer. Next is to calculate particular integral when q is equal to e to the power ax into v, where v is function of x, okay. So to obtain the particular integral when right hand side is e to the power ax into function of x, okay. So in this case particular integral equal to q upon fd means e to the power ax into v upon fd. So in this case you put e to the power ax as it is and particular integral of v upon fd plus a. So this is the rule, okay. Very easy. You put e to the power x as it is and you calculate particular integral of v upon f of d plus a, means in place of d is d plus a, okay. Now an example based on this formula means q is equal to e to the power ax into v. So this is an equation, d2 minus 2d plus 5y is equal to e to the power 2x sin x, means here e to the power ax v in place of v is sin x and a is 2. So this is, So first we calculate auxiliary equation. M square minus 2m plus 5 equal to 0. Okay, so this is very easy second degree equation in m. Okay, so here minus 2 and here 5. So this is by the formula m equal to minus b plus minus b square minus 4ac upon 2a. Okay, so this can be written as 2 plus minus 16 means 4i upon 2. So this is 1 plus minus 2i. Okay, so by the formula, if roots are imaginary alpha plus minus I beta, so CF is C1 e to the power alpha x means e to the power x cos beta x plus C2. Okay, so this is complementary function. Now particular integral. So this equal to e to the power 2x sin x upon d square minus 2d plus 5. Okay, so now by using the formula, when particular integral e to the power ax into v. Okay, so this is the formula. What is the formula? E to the power ax into v is equal to e to the power ax outside, and we calculate only v upon f d plus a. So here this is very easy. This equal to e to the power 2x outside, and we calculate sin x upon, in place of d is d plus 2. So d plus 2 square minus 2 d plus 2 plus 5. Okay, this is. So this is very easy. Only e to the power 2x in multiplication. Okay. So this equal to e to the power 2x. Now sin x upon a plus b square. So d square plus 4 plus 4d minus 2d minus 4 plus 5. Okay. Also we have, since sin ax upon fd square equal to sin ax upon f of minus a square. Okay, so here we will write, in place of d square, here a is 1, so minus 1. Okay, so minus 1, this 4 and 4 cancel, plus 2d plus 5. Okay, so this is e 2x as it is, sin 2x upon 2d plus 4. Okay, now we have, in case of particular integral of sin ax or cos ax, we need d square term. Okay, so first we take common 2 e to power 2x upon 2. Okay, and here sin x upon d plus 2. Okay, so we multiply d minus 2 and d numerator and denominator. Okay, so here e 2x by 2 d plus 2, and here d square minus 4 sin x. Again we have particular integral of sin ax upon fd square, so we put here minus 1. So this is e 2x upon 2 d plus 2 upon minus 1 minus 4 sin x. Okay, so this equal to e 2x by 2, this is minus 5, so minus 5. Now here d plus 2 sin x, e 2x upon minus 10, So we have d means differentiation. So if we operate d into sin x means differentiation of sin x. So cos x plus 2 sin x. Okay. So this is particular integral. Okay. Now solution is by taking y is equal to cf plus pi. Okay. So y is equal to cf is c1 e to the power x cos 2x plus c2 and minus e to the power 2x upon 10 cos x plus 2 sin x. Okay, so this is answer. Okay, so how we solve? So you again see here, this is your equation. Okay, this is your equation. So this is very easy. We can solve many times. So no need to again repeat. Okay, only we will explain particular integral. So here particular integral means e to the power 2x sin x upon d square minus 2d plus 5. So what is the formula? So first we will take outside e to the power 2x and only we will calculate particular integral of sin ax upon fd. Okay, so we have sin ax upon fd square equal to sin ax upon f of minus a square. So our aim is to putting in form of d square. Okay, so only this is the method. So this is very easy to calculate here. Okay, and we get the result. Now this is very important example. Okay, so here this is the equation. So this can be written as d2 minus 2d plus 1y equal to x square e 3x. Okay, so a m square minus 2m plus 1 equal to 0 means m minus 1 whole square equal to 0. So this is very easy. M is equal to 1 1. Here two roots are equal, so CF is C1 plus C2x e to the power x. Okay, now particular integral is e to the power 3x into x square upon d minus 1 square. Okay, so as we know, what is the formula? So formula is e to the power ax upon into v upon f of d equal to, you take a e power x outside, we calculate only v upon f of d plus a. Okay, so this is very easy. So first we will write e to the power 3x outside, and here v means x square upon, in place of d is d plus 3. So d plus 3 minus 1 square. Okay, so now this is equal to e to the power 3x upon x square upon d plus 2 whole square. Okay, so our aim is to solve this by taking in the form of either 1 plus d or 1 minus d. So first we will take common 2. So this is 4 and 1 x square upon, so here 1 plus d by 2 square. Okay, this can be written as 3x by 4 1 plus d by 2 minus 2 into x square. Okay, now by using the formula 1 plus x to the power minus 2. So 1 plus x to the power minus 2 is equal to 1 minus 2x plus 3x square minus 4x cube up to so on. Okay, so here this equal to e 3xy 4, 1 plus x means d by 2, so 1 minus 2 d by 2 plus 3x square means d square by 4, okay, d by 2 square, okay, minus up to so on, okay, x square. Since you see here power of x is 2 and d means differentiation with respect to x, so only this is only d2 is valid because d4 of x square 0, so all the terms will be 0 after this term. Okay, so this equal to e to the power 3x by 4 x square into 1 minus d of x square means 2x plus 3 by 4 d2x square means differentiation of x square 2 times. So first we differentiate 2x and again so 2, and remaining terms will be 0 because d4 of x square 0, okay, this thing. So this is particular integral, means e to the power 3x by 4, here x square minus 2x plus 3 by 2. Okay, so solution is y is equal to CF plus PI. Okay, this is the solution. What is CF? So here CF is C1 plus C2x e to the power x and PI is this thing. So you can write very easily. So this is equal to C1 plus C2x e to the power x plus PI means e to the power 3x by 4, and here x square minus 2x plus 3 by 2. Okay, so this is answer.